Hi, welcome to Digital with Darren. I have a master's degree in physics at Imperial College London and graduated in 1997. I designed satellites at Matra Marconi Space, and I spent 20 years as a quantitative trader on proprietary and flow trading desks in the City of London. Okay, so the next daily coding question is this. It's a question about dominoes. You are given a string representing the initial conditions of some dominoes. Each element can take one of three values. L, meaning the domino has just been pushed to the left. R, meaning the domino has just been pushed to the right. Or a dot, meaning the domino is still standing. Determine the orientation of each tile when the dominoes stop falling. Note that if a domino receives a force from the left and the right side simultaneously, it will remain upright. For example, given the string dot L dot R dot L, you should return LL.RRR.LL. Another example, given the string .R_L.L, you should return .RR.LLLL. So the first thing that I ask myself is what happens if you've got an R and an L adjacent to each other? And the answer is that, well, according to what we see here, or we have to make some kind of assumption to the question, they fall on each other. So the R falls to the right, the L falls to the left here. So they collapse inwards towards each other, and that's the end. Now, if you have lots of dots here, for example, in this one, and even in the top one, you've got 1, 2, 3, 4 dots next to each other. The next pass through, this R will have fallen to the right, and this will turn to an R. I'll put it back to a dot, so you can see. And this L will fall to the left and turn to an L. Likewise, you'd still have a dot left in the middle, and that would need to be dealt with. Right. So let's get on with it, and let's see what we can do. The first thing is I declare a string var s equals, and then we put in the string of the dominoes that we want to investigate. I think I took this one here, the .RL, 4 dots and L. Yes, did. I was using var, but we can use let. That is the more common way of doing it. Right. The next thing is to have some code that we're going to run. So you can see here that I've declared a function called domino drop. Or sorry, I'm calling a function called domino drop, and the function is calling a function from below. Remember, in JavaScript, functions are hoisted, so we can call functions above the parts of the code that they're declared, because when the code is actually run, the functions are hoisted anyways. It's almost as though they have come before the calls. And I do the standard for function creation, which is function like this, and then some function name and parameters and so forth. So that's done. And it takes one parameter. And look how we declare the function just for the point of it. We write the @param, and then we write what's going in there. In this particular case, we're taking a string. S is the input string. So domino drop is the name of the function. Very well named function. And S is a string that goes in. And the first thing I did was just test by writing to the console, the main function ran. And this is the main function. The fact is that we don't need it because we know the main function is going to run, but whatever, it's there. The next thing we do is we declare a new array and we want to split the string. So this string here is not an array at this point in time. It's just a string as far as JavaScript is concerned. So we want to split it into an array of letters, of characters. And they're either going to contain the L's for dominoes that drop left, the R's for the dominoes that drop right, or the dots for the dominoes that haven't had to push on them either way. They might get pushed at the second phase. Again, we don't need to use the var keyword anymore. The more common keyword to use is let. So I'll actually go changing them. Let. The next thing is I declared a blank array. I'll probably be using that later to put the values in. In fact, if I recall what I did, it's to put the next iteration of domino falls in. So if you had a L.L.L. dot, oops, let's do that again. If we had a L.L.L. dot like that, then the next iteration, and I'll even put an R in here just to show, the next iteration would be this. Sorry, the L's are going the wrong way. If this was R, and this one is an L, the next iteration would be this. This one would collapse onto the dot, so this would turn into an R, and this left would collapse here and turn into an L. So that would be the first pass through. But we've still got unfallen dominoes here. We've still got the 3 dotted ones here. And this R will fall again to the right, R, and this L will fall again to the left, L. Now this R and this L on the next pass through, so we've still got this one unfallen domino, will cancel each other out. So this one will always remain upright. And that's my interpretation of the question. Now, I do a console, I log to the console the array, which is the start array. So that's just me testing that it's been split. So these L's and R's that we had that have passed through, which would have come from here in this string, are split into an array of L's and R's. The next thing we do is initialize a loop length. Now remember, we just said just before that, I tab out here, if we've got something like this, these are falling to the right, R, and then lots of dots, dot, and then L. It's going to take time for all of these middle dots to get collapsed. You're going to have the first pass through, which is another R and an L. So that's number 1. Then you're going to have a second pass through. So it's the second loop that we're going to go through. Then we're going to have a third loop. Then we're going to have a fourth loop. Then we're going to have a fifth loop. Then we're going to have a sixth loop. And only at the 7th loop will we have reached our final state. So in a way, what we're doing is we are counting the dots in the middle to determine how many loops we're going to need to go through. And that's what we're going to do here. So initially, we set a loop length of 0 for no other reason than we might assume that they're all R's and L's. This would be a loop length of 0. And in fact, this would also be a loop length of 0. There'd be no domino additional falls to happen. All of the collapses have already happened and the final state is already arrived at. So, and then we pass through it, and all we have to do is, all we're counting for as we loop through the array is we're checking that if the ith element of the array is a dot, then we increase the loop length by 1. So we're just looking for long strings of dots. So this dot here wouldn't count for very much, and neither would 2 dots. But if we had lots of dots in here, that would count. This would increase the loop length. So we're looking for the maximum loop length. So this would be a loop length of 2. It'd pass through and it'd count up a loop length of 2. And that's fine. But when it got here, when it started counting again a loop length. And this time it's counting, this time the loop length is 2, 3, 4, 5, 6, 7, 8, 9. So the length is much longer, and this will determine the iterations. These would have collapsed a long time before. So in this example here, this would collapse in iteration 1, R and L. That would be done. This here wouldn't. The L's would fall this way. We'd have all of these L's to fall. You need another iteration here, another one here, another one here, another one here, and so forth. So 1, 2, 3, 4, 5, 6, like that. You need lots of iterations. So we go through, we count the loop lengths. Then when we pass through the loops, obviously, if we get to the end of one of them, we set the loop length equal to 0. Now, again, just to check that that works, we just log to the console the number of consecutive dots. So that's what we're looking for. The loop length max variable is the number of consecutive dots. And again, I'm just going to change the vars to let. Just because let and constants are more commonly used in the modern version of JavaScript in EMC6 script or whatever it's called. Right. Next is the number of iterations required for all dominoes to be tested. Now, if you've got 20 dots in a row, you don't necessarily need 20 iterations. You actually need half of them because the collapses happen a lot quicker. In particular, if we look at RRR dot and then LLL like this, even though there's 1, 2, 3, 4, 5, 6, 7, 8 of them, the collapses are happening from this side and from this side at the same time. So one pass through has actually collapsed two dominoes. So if the length is 8, it's actually only going to need 4 loops to complete that and get to its final state. We go through the next bit now, which is to iterate through the dominoes to get the various states. So the first thing we do is inspect the leftmost item. So we go to the beginning of the array effectively, which is S array 0. The 0th element is the leftmost item, and we check. If it's a dot, well, we can't do anything with a dot standing, so we need to inspect the next item. So we've got an indented if. If array 1, so the next element is, so we're checking the next element, if that's an L, then the domino falls to the left. And that means that the 0th element, the end element, will become an L, because it will have a domino will have fallen onto it. So that's the first part. And that's the leftmost element. So that's an edge case. And also we've got a for loop, and I'm going to skip the middle part, but we've got a for loop for the rightmost element, which is exactly the same in format. Apart from that, we're using the end of the array, and we've seen this in a previous video. The end of the array is array.length minus 1, because arrays are indexed at 0. So an array of length 10, actually its highest index is 9, because we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 actually counts as the number. And again, we do the same inspection for the dot, and just checking if there's a domino that falls to the right, then it will have fallen on it and knocked that domino over. Otherwise, it will have fallen the other way and left it unchanged. So we've dealt with both of the outside cases. Now we're going to look at all of the dominoes inside. But the reality is, so this is inspect the middle items of the list. The reality is they're going to behave in the same way. The only difference is the checking is going to happen on both sides, because you're not at an edge case, so you can't just have a domino being affected from one side. It's actually going to be affected from both sides. And you've got different cases. You've got the dominoes falling apart, the dominoes falling together, 2 dominoes falling left, 2 dominoes falling right. So we're going to go through each of them. the first thing that we've got to notice is that we've got to start from I equals 1. We're not starting from I equals 0 because we don't care about the edge cases. We've dealt with them. And we're also going to go up to array length minus 2. Again, we're not going to array length minus 1 because that would be the last element, and we've dealt with that on our edge case. So we're going to iterate through all of those dominoes, each one sequentially using I++, so going up the array, each one taking a look and doing our pass-through. Now, the first thing we do is if array equals dot, it has no direction. And we're going to indent our loops here, our ifs. Therefore, the ith array, or the new array that we're going to create, it hasn't changed, it's just going to remain as a dot. Now we're going to go to cases where there is pushing and array changes. So if you've got an L falling on a dot or an I falling on a dot, there's going to be a change. So here's a case where you've got two dominoes falling to the left. If the ith element is standing up straight, but it's one to the left is falling left, well, that's not going to affect it. But if it's one to the right is falling to the left, it's going to turn into a left. So we're doing this AND statement. We're checking if both of these are left, then it's going to be a left. Similarly, if you've got a standing up domino and the one to the right falls to the right, well, that's not going to affect it because it's fallen away. But if the one to the left falls right, it's going to fall on it and turn it into a right. So two lefts turn into a left, two rights turn into a right. And when we say two lefts and two rights, we mean two lefts to each side of the inspected domino or two rights to each side of the inspected domino. Likewise, you can have a domino that isn't falling and a domino that falls to the left. Now, if the right-hand domino falls to the left, it doesn't matter that this one, the left-hand domino, is a dot because the right-hand one's collapsed and pushed, and therefore it's set to an L. And likewise, if the left-hand domino falls to the right, the same thing happens. So that's set to a right. And if there's no dots, if both dominoes on each side are just dots, then it just remains the same. It just remains a dot. And that's pretty much it. We're going to now iterate through this multiple times. So we're going to run the code and see if it works. And let's have a look. We've set our initial value to dot RL, quadruple dot, and then L. So I'm going to just hit F5 to run the code. F5, code running. Let's have a look. Here we go. Let's hit F5 again just to show it running. Right. So this is the start array. And we can see how it's broken down into each element. This is an array rather than a string. The little commas are showing the gaps between the elements of each of the array. So we've taken the string, which is dot L dot R dot L, and we've put them into each item. So the 0th one is this, the first element is this, the element index number 2 is this, the element index number 3 is that, index number 4, and so forth. And the last index, array.length minus 1, is that element is of value L. And we see how many consecutive dots are there. 1, 2, 3, 4. That's the longest number of consecutive dots. Here we've just got a 1 and a 1. Right. The next thing we do is the pass-through. And the first pass-through, we see the collapsing happen. So this L falls to its left-hand side, so it falls onto this domino here, and that turns into an L. So we get two L's. Likewise, the right one falls to the right-hand side and turns into two rights. And this left one falls to its left-hand side and turns into two lefts. Then we do the next pass-through, and we can see that the right falls to the right and the left falls to the left. And there we go. And this domino here The left falls away, so nothing happens. The right falls away, so nothing happens, and it's unaffected. And that's basically the solution as far as we're given from the question. So that's it, and that's the Dominoes question. It was a daily coding question. I've done 100, way more than 100 daily coding questions. Most of them are in Python, and they're all on my GitHub. The address for the GitHub is @dlefgo, which is the same as all of the addresses that I've posted. And thank you for watching the video. So, thank you for watching my video. I hope it was helpful. And if you did like it, then please press the thumbs up like button and also press the follow button below. I will have more programming videos and also some trading and math ones to come too. Thank you very much.